Welcome to my channel. Today we are going to solve one more problem on stack and queue. So right now we have solved two problems on stack queue in our DSS series. So today the problem is we have to implement a queue using stack. Last time we have implemented stack using queue. So it is the reverse thing that we have done in the last video. So let's see how we are going to do this. So we need to modify only this push function. Rest of the functions are fairly simple, so you can easily understand that. But for push there is some change. So logically, to implement queue using stack we need two stack. Okay, so later on you will understand why we need two stack. So let's declare two stack of integer st input, and then we need one more stack, that is stack st output. Okay, so these two stacks we are going to using while performing the operation. So first thing, we have to implement the push function into the queue. So what this push function will do, it will push the element at the end of the queue. Okay, so but in case of stack we are not able to access the end element into the stack. So we only have access to the top element of the stack. That's why we need two stacks. Okay, so first what we are going to do is we need to pop out all the elements till the stack becomes empty. So while this input stack becomes empty, we need to pop out the element from this stack. Okay, so there is a built-in function. One is top element and one is pop, to remove the element from the queue stack. And then what we are going to do, we are going to store this element into the other stack because we want to revert those elements. So st output dot push, so we will pop out all the element from the stack. Okay, so now what we have to do, we have to add our element at where our last element got inserted. So first we have to push the current element into the stack. So push current element into the stack, that is x, and then uh, again we can do this operation, but on output stack. Okay, the temporary stack which we used for storing the element. So using this output stack, till this output stack is not empty, what we are going to do, we are going to take the top element of the stack and pop that element and insert into the input stack. So in this way the push operation of a queue is achieved by using two stack. So for safer side, what we can do is we can declare this stack as locally as well. That will also help. Okay, now to remove the element from the queue, we have to implement the pop function. So for this pop function, what we are going to do is we have to just pop out the element and return that element. Okay, so we first collect int I rate is equal to top of the stack, and that will be the element which we are going to remove from the stack. So str pop will do that, st input dot pop will do that, and then return I rate. Okay, so this in this way we are going to return the element for pick operation, like that is the first element we have to return from the queue. So that we can just return by using top operation, and if the if the input queue is empty, that means input stack is empty, that means queue is also empty. So we have to just implement this. You have to just return the value from empty. So hopefully it will work. So let's try to run this code. Yeah, our solution got accepted. So let's try to run it for all the test cases. Mm, yeah, correct. So our solution got accepted for all the test cases. So in this way we have implemented a queue using two stack, but the second stack is needed only at the time of push operation, because we have to pop out all the element, then insert one element, and then we have to push all the element which we previously popped out, so that it will get a FIFO behavior instead of LIFO behavior. Okay, so I hope you got the question and got the answer. You can find this uh, solution on in my GitHub repo. I will put the link into the description box. If you found this video useful, then please like the video, share it with your friends, subscribe to my channel, and press the bell icon for future update. Happy coding. Thank you.